Okay, well, I am going to hope that that works a little bit better. It seems like things are working, so go ahead and let me know if you cannot hear anything. But I'm going to go ahead and say that hopefully this is working. So again, sorry for all the technical difficulties. It seems like YouTube was having some problems playing the audio from our last stream, but it seems to be working this time. So not 100% sure what's up with that. I'm going to double check that it seems to be working now. For myself, you might get some, oh, you can't hear anything. Working, so go ahead and let me, cool, it seems to work. And it's a little bit dark, so let me adjust that as well. There we go. Okay, sorry about all the technical difficulties. So this workshop, we are going to be talking about Intro to HTTP and web servers, which is kind of an exciting way of saying what even is going on with the web. This is the wrong... Okay, don't know what's going on with that. Yeah, so we're going to be talking a little bit about HTTP and web servers. The idea behind this workshop is basically, let's say that you're, for example, Facebook, and you want to make a web application that is supposed to be for a bunch of different people. And you're thinking, hey, am I just going to run Apache and have a program generate hundreds of thousands of HTML files in a directory? Is that how that's going to work? And of course the answer is no. And so we're going to talk a little bit about how you can make a website in the same way that Facebook might make a website, in such a way that it's dynamic, in such a way that it doesn't require you to use Apache to make a bunch of files on a website, in a directory on a hard disk, in such a way that it's really more flexible and is being generated directly by code. So it's going to be the topic for today's talk. As with last time, feel free to post any comments or anything like that. I have the chat right in front of me, so if anyone has any questions, comments. Again, there's probably about a 30-second delay, so it'll be a little bit more challenging, but we'll make it work. So when we're talking about HTTP and web servers, I wanted to actually start off by just talking a little bit about what is a web server, and even more generally, what is a server? So servers, probably magic, right? When you think servers, a lot of people think a data center, a building that has lots and lots of computers. They're thin computers with lots of flashing lights, mounted in racks, and with a bunch of cables running to it. And in fact, that is the way that most companies do run servers. They are often in what's called data centers. Even at my house, I have a small server rack just for some things that I run myself. So you can put servers in a rack, but what are they? Are they some sort of special magical machine that just makes things work? Well, probably not really. And if you're at all familiar with multiplayer gaming on the PC, for example, Minecraft, you probably know that you can run a Minecraft server on your home computer, on your actual desktop computer. So what is a server? Well, a server is not a magic box. A server is just something that provides services for other computers that we call clients. Provides services for other computers. That's pretty generic, right? A server is a program. And again, provide services is a very generic term. That could mean a lot of different things. There isn't really a solid specification for what makes a server. A server is just something that provides some sort of service that other people, who we call clients, can use. When you talk about having a server, someone says, I have a server, usually what they mean is they have a computer that is meant for only running server programs. Because again, a server is a program. It is something that provides a service. When someone says they have a machine that is a server, what they mean is they have a machine that only provides services to other people. It's not meant for desktop gaming. Oftentimes servers will run what we would call headless, meaning they don't have a monitor attached to them. If something goes wrong with the server, you have to diagnose it all in a command line. Usually they won't have often they won't have a visual thing at all. You can't click on a button, there's no mouse. And again, often, if someone does have a machine, it'll be in a rack, in a data center somewhere with lots of flashing lights and cables. But The programs themselves are the server. So what we're going to talk about today is how we would build one of those server programs to be a web server. So that's kind of the important thing to know, is that when we're talking about making a program that's just going to provide a service, and that service is going to be speaking HTTP, which we'll talk about a little bit as well. But you don't need to have a server running in the cloud. All you need to have is your personal, my laptop runs servers. And in fact, I'll set up a server with you today and we'll see how that works. The other thing that you really need to know before we start talking about this too much is what we call a protocol. A protocol is just an agreed upon way of exchanging information. It's something that follows some written down set of specifications that everyone has agreed on make up that protocol. So an example of a protocol, you almost might consider English as a sort of protocol. People are able to exchange information with each other because they've all agreed on the definition of a bunch of words. For the most part, people don't always agree on all the definitions of all of the words, as I'm sure we're aware. But English is kind of a protocol in a certain sense. If we get a little bit more complicated, there's probably some other protocols you can think of. Maybe you've written a protocol at some point. Maybe you've written a command line application and you give it certain commands, and those certain commands do specific things. That's kind of a protocol. It's kind of a protocol between you and a computer, and a computer program specifically. Probably not what most people would consider a protocol, but it's kind of a protocol. Again, it's just an agreed upon way of exchanging information. So the information comes in a specific format. You can write, code that will read that specific format, that can speak that specific protocol. And we'll look at an example of protocol basically on the next slide. Because HTTP, that thing that you see at the beginning of URLs, http://youtube.com, HTTP is a protocol. It's the Hypertext Transport Protocol. That's what it's short for. It's a protocol for loading things on the web. And again, HTTP, you've probably seen HTTPS more and more. That's literally just HTTP, but they've encrypted all of the protocol stuff, and it's encrypted in a different way. But it is underlying, it is just HTTP. It's just encrypted. You don't have to worry about the encryption. There are programs that will take care of it for you. HTTP is a protocol, and again, it's a protocol for loading things on the web. So that's all very abstract, and maybe you're thinking, okay, what is this protocol? Is it a bunch of binary? Do I have to look through a bunch of hexadecimal? Is it really, really complicated? And for many protocols, the answer would absolutely be yes. There are a number of protocols that are very, very complicated and, binary and all sorts of weird stuff going on. HTTP is not that way. HTTP is plain text. So here's what an HTTP request looks like. If you look on the left, that's the request. When you request tyler.vc/test.html, this is the text that is actually going to be sent to the web server. It is literally plain text, and you'll see there's a get/test.html, http/1.1, and then on the next line it says host:/tyler.vc. And you can't see it, but there's actually two. You hit enter twice after that. And then the server will respond. And it responds http/1.1, 200 OK, content length, content type, connection, and then the HTML underneath. And again, there's two new lines between what we would call the header and the actual body. But this is the protocol. It is literally plain text. That's one of those things that really does surprise people. You can speak HTTP. You don't need to really know anything. You just need to know some basic English and the format of what order the words go in. So I'll actually show you an example. Let's see, it's right over here. So if I go ahead and type telnet, you may not have this program installed. I'm going to go ahead and zoom in as well so that people can see this a little bit better. Terminal zoom. Gotta be a keyboard shortcut for this, but I don't know what it is. Okay, so I'm going to go ahead and type telnet, tyler.vc 80. What does the 80 mean? 80 is a port. A port is just a number. A computer, when it sees that port number, it just sends all of the requests to a specific program that's running on the computer. So your program can ask the computer to send all network traffic on this particular port to your program. But it literally just means somewhere in the network there's a number, and that number is 80 instead of being something else. It's sent along with the rest of the traffic. It's nothing magic again. It's literally just a place where there's a number, and the computer decides to do things with that number. It turns out that for HTTP, the number is 80. It's always 80 unless you specify that it's something else, and we'll see how you do that in a second. For HTTPS, it's 443. There's a bunch of other things, but in this case, we're going to connect to 80 because that's the standard HTTP port. So I'm going to type telnet tyler.vc 80, and it'll say, oh, hey, it's connected. And what was that we type? Oh, yeah, it's get. There is no test.html, but let's actually go ahead and try it. So get test.html http/1.1 host tyler.vc. I hit enter twice, and there's all the stuff. And you'll see this is actually the HTML for a page not found error. If I scroll up, you'll see, oh, hey, here's the things. This is actually apparently a bug because it shouldn't be saying 200 OK. But you can see I've made a request in plain text. It responded in plain text. And then after the plain text response, it gave me back all of the HTML. It's pretty cool, right? It is literally just plain text. If I want to, I can also type get /http 1.1 host tyler.vc. And hey, here's another response. And then this one, there's no HTML at all. It just says HTTP 1.1 301 move permanently. So again, it's literally just sending text to a server. That's all HTTP is. It's not magic, nothing special. It is literally just sending some plain text to a server. And again, a server is what? A server is a program that is providing a resource. And in this case, the resource is returning some HTML. So let's look at some more HTTP requests, how things work. People often joke in technology about 404, file not found. Where does that come from? Where does the 404 come from? The 404 comes from the response, that little bit of text that we saw at the very top, right? This is what the server actually responds with. It responds with plain text, HTTP/1.1, and then it responds with a status code and a status message. And if a file is not found, the status code is 404, and the text is file not found. So again, there's where that bit of magic comes from. It actually comes from the response. Where is it that the 404 is coming from? Well, there's a list of them. If you go on the internet and you search for HTTP status codes, you can actually get a list of all of them. Here's all of them. And the first number actually means something different. So things starting with 1 are informational. Things starting with 2 are successful. So on and so forth. There is a bunch of them. So, what are some common ones that you might see? Well, let's go back to the previous slide. When something goes right, the status code is 200 OK. When something goes wrong, it's 404 not found, file not found. If there's a server error, it would be 501 internal server error. If you want to redirect someone to a different page, it's going to be 203 found or 202 moved permanently. There's a whole bunch of them. There's actually a joke one, 418 I'm a teapot, which is for the joke proposal of making an internet coffee brewing protocol. There are jokes made every year about protocols, and one of them was the coffee brewing protocol, and 418 is I'm a teapot, if I'm not mistaken about that number. I think it's 418. There's a whole bunch of them. Some of them are require payment. There's one for length required. I'm not entirely sure what that's used for. Forbidden. There's a whole bunch of them. You can look up the entire list if you want to. Now again, what does that number do? Well, it's up to the web browser. The web browser can do whatever it wants with it. But it's there. Again, if you provide HTML as well, it'll display that HTML. If you only provided this, the web browser would just display its default error page. What's a post request? If anyone's ever done a post request, maybe you've made a PHP website and you have a form and you want to submit the form and it's a post request. Well, what does that do? It sends this little thing up here as post. So previously it said get, now it says post. That's it. Nothing special about it. It's just changing a bit of text in that one particular location. And then whatever the data is that you're sending with it, so in this case, if I had two fields, parameter and also, and their values were value and another, it sends it down here in this format. And again, that's after 2 enters. That is all of the magic of post, right? It is literally just sending some text. And again, we can see that maybe the server wants to, redirect the person to a different page now that they've posted to this web page. Well, you send a 302 found, and you send a location is, this particular URL. I think I said 203 earlier, but it is 302. That's how it works. HTTP is literally just a bunch of plain text. There's nothing special about it. It's an agreed upon thing. Web browsers will do specific things given when it gets that text. Web servers will do specific thing when they get a text. But you can actually control the web servers. You can make the web servers do whatever you want when they get a certain text. Because again, web servers are always going to get text in this particular format, and then they just need to respond in this particular format. But it's nothing particularly complicated. If you actually think about what does a web server do, well, I wrote some pseudocode here. I wrote some general concept code of what it would do. So the first thing a web server does when it gets a request, let's say maybe you've heard of Apache or you've heard of Nginx, which some people call Nginx. When one of those web servers gets a request, an HTTP request, what it does is, first of all, it reads this text and it looks for the file name and the host being the domain name. So my host would be tyler.bc. So that's the first thing it does. The second thing it does is it reads its config file and it looks for the configuration section related to that host. So in this case, the host is tyler.bc. It finds this configuration file for tyler.bc. And it sees, oh, hey, all the files for tyler.bc are in var www. So then it goes to var www and it looks at this, this file name, and it sees, oh, hey, I have that file name here, so I'm going to use that file name. And then finally, it returns the text from that file with the HTTP headers on top, which again, would look something like this. And then it's just going to return the text to the file. That is what the code for a web server would roughly look like. Obviously, it's going to be a little bit more complicated. It's going to do a little bit more than that. There are some other things we need to consider. But that is the most generic version of a web server, is read a config file, find the directory, and then return the HTML from the file back. Or if it's a JPEG or whatever else. That's pretty much it. If you think about that, though, files aren't really necessary. There's nowhere in that thing that I said, in HTTP, when we said this is HTTP, this is how HTTP works, there is nothing in HTTP that says this is actually what is required. It is not required that the web server go out to, to a directory on a disk, find a file, and then return back the content of that file. There's nowhere in there that it says that has to be the case. So we can actually make the web server do anything we want as long as it speaks HTTP. And again, a web server is just a program, and we can write a program. So we're actually going to look at how we would write a web server now. And I will actually go through sort of a sample web server in Python. Now, I'm going to use Python. You can use pretty much any web language you want. You could use, PHP as a web server thing, but PHP usually requires another web server to work. You could use C#. You could use Java. Go is a popular one recently. You can use the Go programming language. You could use C++. You could use C. You could use assembler. And there is a person I know who writes all of his web servers in assembler, which is sort of machine code, right? It's the lowest level really that you can go. We're going to use Python because it's pretty easy. And how do you do it? Well, again, we're going to need to receive some text in the HTTP format. we're going to need to do something based on that text, and then we're going to need to respond with our own text in the HTTP format. Those are sort of the 3 steps. Receive, do something, respond. Now we could code all of this ourselves. All we would need to do is read the text. We would need to parse out the different parts of the text. And then we would need to, again, we would need to respond back in the proper format. We could do all of that ourselves. However, there are a bunch of people who've already done most of the hard work for us. So we're going to take advantage of that and not actually do it ourselves because, it's always easier to use someone else's work. So we're going to take advantage of some like a programming framework that will do the first part and the third part. It will receive the text and dispatch the program to do something based on the HTTP text, and then it will respond with its own. It will respond with its own text. So all we need to do is return back some text, and it'll take care of everything else for us. And in fact, it'll even take care of deciding what code to run based on this part over here. Where is it? It's in here somewhere. This part, this file name and this host. It'll take care of deciding what code to run based on that. A really simple one for Python is called Flask. And Flask is something you can just install. You would just need to run pip install Flask. If you don't have pip, you need to install pip. Pip is the Python package manager. But all you need to do is you install Flask. This is the code for running Flask. And here's what an actual demo application would look like in Flask. And I actually have this copied down in my terminal, so we'll actually take a look at what that looks like. Let's close out of this so it stops doing that. Cool. I think it's this one? Yeah. Okay, cool. So, and let's see if I can zoom in just a little bit more. Just so it's a little bit easier to see. Okay, so here's our code. We import Flask. We set up a Flask app. So this is assigning this is creating a new instance of Flask, which is a class. It's creating a new instance of it, and it's assigning it to the Flask variable. We have this app.route. We'll see what that does in just a second. There's this function called hello, and all the function does is it returns hello world, and then we have this bit down here which runs the app. You don't really need to worry about this. This is kind of a standard Python thing, but you could actually do this as well. And I'm using Vim, so don't worry about what's going on with key commands. But that is actually our Flask app. So let's go ahead and run this. And hey, it says running on 127.0.0.1:5000. Remember how I said that 80 was the standard port for web stuff? We're going to use 5000 in this case because it's just decided, hey, I'm going to use 5000. I'm sure there's a way to change that. I would probably Google Flask change port if you wanted to run it on 80, which is the default. So you wouldn't have to do that colon part. But we're going to go ahead and go with the colon part. 127.0.0.1, which means local machine. That is a defined address that will always go back to your local machine. Colon 5000. And it says, hello world. Now again, remember, we did not have anywhere in Flask an actual file that was read. It is not reading a file anywhere. All it's doing is executing that code right here, and it's returning the result. Right? Def hello, return hello world. Now what's this app.route thing? Well, that's actually telling Flask this part that we would normally put a file in, test.html. We would normally put a file somewhere. The app.route is telling Flask what to do with that part. So let's try making another one. App.route test.html. Now, .html doesn't matter. We can get rid of that as well. So let's go ahead and do that. Because again, we're not actually loading a website. Def hello 2. So we're going to make a new function, return hello. This is the second test. Go ahead and write, and then we'll rerun our web server, because again, a web server is just a code, and we're getting some sort of errors. URLs must start with a leading slash. So URLs must start with a leading slash, so let's start a slash right there. Cool. So it's running again. We'll go ahead and go back to our web browser, refresh, and we'll go to /test. And hello, this is the second test. Hello world. So again, now we've made 2 URLs. And again, both of this is just code that's running in the web browser. So what are some things that we can do with Flask to make things more complicated? Well, let's go to, is there a getting started guide? Maybe, no, okay. Snippets, here we go. That looks a little bit more complicated. What about overview? That's where we were. Docs. This is exactly how I would use things. Quick start, here we go. So let's look at some examples. Here's how you would change the port, by the way, it looks like. It's got a debugger, that's cool. Okay, cool. So here's an example of something cool we can do with Flask that will make things a little bit more dynamic. You can see right here it says that if we put something in brackets, it will pass it in as a parameter to our function, right? So we put things in these pointy brackets and it passes it into a parameter. So let's go back to our code and try that. Test. Let's make an endpoint called welcome. Welcome, spell it correctly, name. It will take in a name, and it will welcome someone. And again, what we were saying with Flask is it looks like if we put something in pointy braces, it's going to pass it into a function. So this function is, we will just call it welcome. Turns out it doesn't matter. And then name. So let's go ahead and say hello name. This is the second test. We'll go ahead and run that. And again, we changed the URL, so now it's welcome Tyler. Hello, Tyler. This is the second test. We can try a different URL. Let's try my name in all caps. Hello, Tyler. This is the second test. Hello, test. This is the second test. Now again, remember, thinking back to a really simple web server where we have a bunch of URLs. We have a bunch of URLs and they all map to files on the file system. It would be really impractical to make something like this. You would need a directory called welcome, and it would need to have a file for every single person, every single possible name. That's not practical. So instead of doing it that way, what we do is we generate it all automatically. We have a program that rather than mapping URLs to files on the file system, instead maps URLs to functions. And the result of those functions is what's returned back to the web browser. And in fact, if you want to take a look at this, let's go ahead and open a new terminal. I actually don't want this type, I want this type. And I'm going to zoom in a little bit. Promise I will map a keyboard shortcut to this next time. So let's try telnet again. This time we're telnetting to 127.0.0.1, which is the local machine, and the port is 5000 instead of 80. So now we want get/http 1.1 host, doesn't matter, 127.0.0.1. We don't have different domain names. It says hello world, and then it quit. Let's try a different one. Get/welcome/Tyler, http 1.1. Host 127.0.0.1. And it says, hello Tyler, this is the second test. Again, all of this is not magic. All of this is just plain text. All this program, this Python program is doing is responding to that text in that particular format with other text. Now, your question is, well, where does HTML come into this? Well, instead of returning just a plain string, we can return HTML. We can make this an H1. You know, maybe this is a paragraph. Now if we run this again, and we go back to the main page, hello, world. Now it's just returning HTML. And again, if you look at the source of the page, you should see that it is in fact exactly the HTML that we're sending it, which is not even really properly formatted HTML, so it's not super happy about that. But that's pretty much how it works. All of those URLs are mapped to a particular function in Python, which is really, really cool. The way that we tell Python what function to map it to is we just do these app.route, and then we give it the URL that we want it to map to. And we can do those dynamic URLs, which is kind of cool. What are some other things we could do? Well, again, we could do post requests. So let's say you want to update something on a database when someone does a post request. How would we do that? Well, first of all, we need to make a post, a form. So let's make a form method equals post. Can't use, gotta escape those. Action equals, action tells it what URL to request. We're going to do post test. And then it's going to have an input type equals text. Name equals test. And then we're going to end our form so that now if we run our code again and we refresh the page, we'll see this completely blank text box. Super exciting, right? Completely blank text box. But now let's actually go ahead and make something so that when we post to that, it actually does something. So at app.route, post test, def post test. Okay, so now how do we make sure that Flask knows this is a post request? Well, here's what I'm going to do. I'm going to Google Flask post. And it looks like it's right in here, post. That is a different type of post. Let's try this one. This one's broken. Let's try this one. Okay, it looks like request.method, request.form. Cool. Where does request come from? I don't know where request is coming from, but apparently it's a variable that we have access to. So we can pass in this into the app.route. So methods equals. Methods equals post. So we're telling it this is going to accept post requests, and then we're going to say that we want to get the test variable. So the test variable is going to be request.form, request.form.test. And let's return that. See if this works. I haven't tried it before. And we get an error, so that's cool. So again, this is literally just a program. So we'll go in here and we'll see, oh, hey, here's the error. And this error is not super useful. Global name request is not defined, so that's what I was confused about as well. Looks like this is the answer. I'm not entirely sure what this is. Oh, okay, from Flask import request. So we're missing an import. We'll go ahead and run this again. Oop, and I misspelled Flask. So let's fix that. And we'll run it, and it looks like it's working now, and we'll retry our request, and we're still getting an error. So what's our error this time? Immutable multi-dict. So my guess is it's supposed to be like this. Let's see if it works this time. Cool, it works. So now, we have this form right here, and I can fill something out. Let's say this was a username and password form. And, in this case, it's just checking my username. But let's make our code a little bit more complicated. So now that we have a username, maybe let's go ahead and make a login function, right? So we're going to make the name of this field, instead of being test, it's going to be username. And we'll make another one. Type equals password. Name equals password. So now we have a username and a password. Username is equal to getting the username from the form. Password is equal to getting the password form. And now we can do if username is equal to Tyler Menezes and password is equal to Hunter22. Print welcome. Else print denied. More exclamation marks for denied. Go ahead and run this again. And if I go back to our main page, we'll see that if I refresh, I now have a username field and a password field. If I type the right one and hit enter, it doesn't work. So let's go ahead and add a submit button because we need a submit button. Where are we? Here. Okay, we needed a submit button. This is all HTML. If you don't know HTML, we could totally do like a workshop on that separately, but I'm not going to cover it too much in this. So what I did was I made a form and Hunter22 submit query, and we got an error. So let's take a look at what our error is. This happens all the time to everyone. View function did not return a response. So that's interesting. Oh, it says print instead of return. It's correct. So we need to return a response. And in fact, you can see on the command line it did print something, but it did not return it to the web browser. Because print is going to go to the command line, return is going to go to the web browser in the way that this particular thing works. And again, this is all just a program. So you could make that do whatever you want. But in this particular case, they've made it so that anything that's returned goes to the web browser. Anything that's printed goes to the console. And LastPass asks me if I want to save it. Okay, so let's try Hunter22. And it says welcome. So our password was correct. Now, on the other hand, if we type some random string of text, it will say denied. So we just made the world's simplest login function. Now, what could we do with that login function? Well, all sorts of things. Because again, HTTP is just a bunch of text. We can make our program do anything we want. We could set a cookie. If you want to know how to set a cookie, again, we're using Flask, which is a Python thing. Set cookie, spelled set cook. And it looks like here is how we set a cookie. So we could set a cookie. And then we could read that cookie. So we could make sure that someone is logged in before doing anything else. So every function that is supposed to, for example, be an admin function, maybe we could check if they've logged in as an admin. That is something that you could do. Really, pretty much anything you want is theoretically possible in this case. Anything that can receive text, do something with that text, and respond with different text is possible. That's really all HTTP is a method of exchanging that text in a particular format. It's not even a method of exchanging it. I mean, it is literally just a format for that text. Doesn't know about HTML, so you could also return images. You could return downloads. You could return all sorts of different things, PDFs. Really, anything you want. It's all about just that particular format. So if I were to also, for example, let's go into an example of a different, slightly more complicated program. So if I were to go into the code for Student R&D's code day management platform, there's actually a lot more code. So let's go into email, for example, flyer controller. So this is actually, you can see that this is going to be a function that gets run, which actually generates a poster. And it returns a PDF of that poster, which is kind of cool. If you actually go back, let's go to a simpler one. Let's go into Student R&D www app HTTP controllers. if you go, for example, to Student R&D's website, you are going to our website. Where does all of this come from? Well, all of this actually comes from this function right here, get index. And it goes ahead and it runs all of this stuff. Now, what if you go to the, the trademarks page? You go to our trademarks page. Well, hey, where's that coming from? That's coming from this function right here. If you come to our code of conduct page, it's generated from that function. Now, what if you have something more complicated? What if you have a page that's a little bit more complicated? We have a page that can list live events. Well, the live events page does some more complicated code, and then it returns it. We have a page where people can RSVP to things. That's also in there as well. All of that sort of stuff is just code, right? So you actually go to a live website like Student R&D's website, and it is in fact just code. Facebook's website is in fact just code. It's a bunch of functions that get run when you hit specific URLs. In fact, I think a while ago, Facebook accidentally leaked some of their code back in 2007. So this is almost 10 years old now. But Facebook did in fact leak some of their code. It was returning the code instead of executing it. And you can see this is the really basic version of PHP of Facebook's code. And it looks quite complicated, but you could actually look at some of their code as well. All of this, none of it is generating HTML files. All of it is just running code based on what the HTTP request looks like. So that's pretty much it. That is it for the workshop. Basically, your next steps are pick a programming language. I would recommend Python because it's really easy. If you're already really familiar with something else, do it. Except I would say Java is really complicated to get a web server running. I don't know why. No one has made a simple web server class that I've seen for Java. But everything else has usually a pretty simple web server class. I would recommend Python because it's got the really simple one called Flask. So I'd search for Python Flask, F-L-A-S-K, and just read the docs, install it, and try making a sample web server and see if you can get it working. Once you get the really simple stuff working, that's when you start getting into the more complicated stuff. There are things that will help you with some of the more complicated features that you might want to use. In PHP, because our applications are really complicated, we use a framework called Laravel. Python has its own. I think Twisted is a really common one if you want to do weird live stuff. There's some other ones. It's like, I can't remember the names of any of them. Flask is a really basic one. And for those starting ones, you usually want a really basic one, because if you're new to this, it's much easier to figure out what's going on until you need more complicated features. So again, next steps, I would Google Python Flask, get started on that, and see what you can do from there. So if anyone has any questions, I will go ahead and take any questions that you have now. Again, go ahead and post those in the chat. I have that up on the screen. And again, while I'm waiting for the latency to resolve itself, in case anyone does have any questions, I just wanted to mention tomorrow we're going to have our last workshop, which is going to be on game design. I will try to solve the technical issues that we had this time. I apologize again for that. Apparently this is a known problem sometimes with YouTube Live, so maybe we'll switch to a new platform in the future. But tomorrow's is on game design, again, noon. And we'll talk a little bit about what makes games fun. Any questions at all? Okay, cool. I'm going to call that good. If you do have any questions, don't hesitate to post them in the Student R&D Slack. If you're not in our Student R&D Slack yet and you're watching this video recorded, go ahead and get in our Student R&D Slack. It's awesome. There's a bunch of students working on cool projects, and it's a great place to get help. You can always visit, I think it's s5.srnd.org. You can sign up for an account there, and you'll get instructions on setting up your Slack account from there. And then the other thing to keep in mind is, again, all of these videos are being recorded, so if you want to go back and rewatch, you missed something, whatever, feel free to do that. It should be available immediately afterward. So again, thanks for your time so much, and hope to see you again tomorrow.